Okay, so in the last video we got cut off. But so for where we were doing the second round, we're working on number 3, the second round of answers. So we got the 5 pi over 12 plus 12 pi over 12. So that gave us 17 pi over 12. And then if we take our 7 pi over 12 and add 12 pi over 12 to it, we'll get 19 pi over 12. And then for our final answer, we'll take our 11 pi over 12 and add 12 pi over 12. And that'll give us our 23 pi over 12. So we really have 8 answers for this problem, okay? So just to remind you, because we had this 2x here, we had to do 2 rounds of answers, okay? It really just goes around the unit circle once, because 23 over 12, think about that's close to 24 over 12, so that's close to 2 pi, which is around the unit circle. So the reason you have to do the 2 rounds is so that you get all the answers that would be on 1 round of the unit circle. Okay? So let's take a look at number 4. So number 4, we have the square root of 3 tangent 3x plus 1 equals 0. So there's no factoring here, there's no rewriting, but keep in mind we're going to have this 3x here. So normally the domain is from 0 to 2 pi. This time our domain is really from 0, and you have to do 2 pi times 3, so from 0 to 6 pi. So what does this mean, and how are you going to do the problem? This means that we're going to have 3 rounds of answers in order to get all the answers on the unit circle. So what you're going to be adding for each round is always 2 pi, which is just a circle, over, because it's 3x, you're going to do 2 pi over 3. That's what we'll be adding. So when we get to the part where we have the rounds, we'll have to make sure we use that. Okay. Alright, so first thing, just to get this, we want to get tangent 3x by itself. So it'll be equal to -1, and then divide by our square root of 3. Okay, so once again, we have this 3x. We can't do anything with that 3. It just tells me 3 rounds of answers. So before I go look at my unit circle, remember for tangent, that's y over x. Okay, y over x, and if we want to have square root of 3, we know we have to do the 1/2 and the square root of 3 over 2. Because the square root of 3 is in the denominator, that's where the square root of 3 over 2 has to be, and the 1/2 has to be in the numerator. So we're looking for when x is the square root of 3 over 2, y is the 1/2, but because our answer is negative, one of them has to be negative. So x is square root of 3 over 2, y is 1/2, right over here at 5 pi over 6. So we get 5 pi over 6, but remember we have to set it equal to that 3x. Okay. And then for the other answer, if we look over here at 11 pi over 6, that is the other place where we have the correct thing. So 3x equals 11 pi over 6. Alright, we have to divide by that 3, so this is going to give me x equals 5 pi over 18 as one of my answers. And x equals 11 pi over 18. So think about 11 over 18. That's not anywhere, that's not even close to 2, but much less that's not close to 1. So we have to do 3 rounds of answers. So to get our next round, remember you're going to do add 2 pi over 3 because we're doing 3 rounds. Now I want to go ahead and change this to have a denominator of 18. So this, if we were to change the denominator here, if that's 18, we did 3 times 6. So 2 times 6 would mean we need 12 pi on top. So we're going to take 5 pi over 18, and we're going to add to that 12 pi over 18. So another one of my answers is going to be 17 pi over 18. And then we're going to do the same thing with 11 pi over 18. So another answer is going to be 23 pi over 18. Okay, so guys, this was the first round, and this is the second round. We have to do 3 rounds because it says 3x, and because 23 over 18 is not close to getting to 2 yet. Okay, we need to be around 36. So to do our next round, same kind of thing. You're going to add 2 pi over 3. But because I need my denominator to be an 18, that's 12 pi over 18. And you'll get where you can just do this, where you can just really add the numerators. So if I do 17 pi plus 12 pi, that'll give me 29 pi over 18. That's another answer. And then 23 pi over 18 plus 12 pi over 18. And that'll give me 35 pi over 18, which is getting very, very close to that 2 pi. So we had 6 answers total here. Okay, we had 1 round, 2 rounds, 3 rounds, but we really just went around the unit circle one time, and it gave us all the answers that we could have. Okay, so let's look at number 5. Alright, so one thing to notice here is number 5 does not have the 2x or the 3x, so we will not have to do the rounds. So it will just have a regular domain there. And the domain is not required that you write this here. It just kind of helps you see what's going on. So it's just going to be a regular problem. The only problem we do have is that these are 2 separate trig functions. And remember, in order to factor or to solve, you have to have all one trig function. And unless there's that weird example where you can do like the number 2, or we could factor by grouping. So if you want to change these, you should change the one that's squared. So I want to change tangent squared x. So if you remember those Pythagorean identities from the first day, we know that 1 plus tangent squared x is equal to secant squared x. So if we rearrange this, tangent squared is secant squared x minus 1. So instead of tangent squared, we're going to put secant squared x minus 1. Keep everything else the same. And then I'm going to distribute out that 3. And I'm going to go ahead and move over that 4. Alright, in order to factor, we're going to want this to be in descending order and all of our terms combined. So we're going to have 3 secant squared x plus 4 secant x plus 1 equals 0. So we're going to use long factoring because we have this 3 out front. So 3 times 1 is 3. 2 numbers that multiply to 3 and add to 4. 3 and 1. Bring down our first term. Middle terms are going to be plus 3 secant x and plus 1 secant x. And bring down our 1. And then we'll have grouping. GCF is 3 secant x. That'll leave us with secant x plus 1. GCF here is just 1. That'll leave us with secant x plus 1. Insides are the same. So one factor is secant x plus 1. Other factor is 3 secant x plus 1. And we know that's equal to 0. Alright, so we can split these down the middle. Once again, these are just x's here, so we do not have to do the multiple rounds. So we're going to have secant x equals negative 1 for the left-hand side. Okay, so guys, if you can't think about secant, think about secant goes the reciprocal with cosine. So this is the same thing as cosine x. If you do the reciprocal of negative 1, it's still negative 1. Okay, that means the same thing. So where on the unit circle is the cosine or the x value equal to negative 1? And that happens at pi. There's that answer. Okay, for the right-hand side, we're going to have secant x equals negative 1/3. Okay, let's think about that in terms of cosine. So cosine x, because that's the reciprocal, if we take the reciprocal of this, that's negative 3. Alright, so remember back to like the first problem where we had a bigger number. So on your unit circle, do we have negative 3 anywhere? No, it only goes up to 1 and down to negative 1. Okay, so this is not going to be an answer on this side, so the only answer we have here is pi. Okay, check all time. Okay, so for the next problem, so problem number 6. Okay, so if you notice here, we have a couple different trig functions, and we only need one trig function. You can also notice that we have just regular x's, so we're not going to have to do the special domain. So domain is really just one round, 0 to 2 pi. Okay, but I can have all these trig functions. So the one that I see that I would probably want to rewrite is cotangent. Cotangent is cosine over sine. Well, because we have a sine in the numerator and denominator, we can cancel those out, which helped us here. That fixed it, where now we're just working with cosines. Okay, so I'm going to put this in the correct order. Now, here for our factoring, we don't have that coefficient by itself, so we're just going to be looking at a GCF. So our GCF that we have here is just cosine x. If we take out cosine x, that'll leave us with 2 cosine x plus the square root of 3. So we're ready to split it down the middle. On the left-hand side, we have just cosine x equals 0. So on your unit circle, your cosine or your x value where it's 0 happens at pi over 2 and at 3 pi over 2. And then on the right-hand side, if we solve this for cosine, we're going to get negative square root of 3 over 2. So we're looking for when the x value is negative square root of 3 over 2. So that happens at 5 pi over 6. And that happens at 7 pi over 6. So we have 4 answers for this problem. The reason we're only doing one round of answers is because we just had an x here. It wasn't the 2x or 3x. So that gives us the complete answer.